Greetings everyone. I'm Darshini and my teammate name is Devadarshini, and today I'm presenting our final year project titled Crowd Detection in Aerial Images using Spatial Graphs and YOLO V8. This project focuses on detecting estimating crowds from drone images for applications like surveillance, disaster management and public safety. Problem statement. Crowd detection in aerial images is challenging task because people appear very small due to high altitude. There are also issues like scale variations, dense crowd formation, occultation, and complex backgrounds. Traditional image processing and normal CNN models often fail to detect people accurately in such conditions. So, our project aims to solve this problem using an advanced deep learning approach. The main objective of our project is to develop an efficient crowd detection and density estimation system like using YOLO V8. Our goals are to detect individuals accurately in aerial images, to estimate crowd density, to generate density maps, to support real-time applications like smart surveillance and emergency monitoring. Dataset collections and pre-processing. For this project, we use aerial crowd datasets such as UAV crowd and VIS drone. This pre-processing steps include resizing image to be fixed size, normalizing pixel values, splitting dataset into training, validation, testing sets, applying augmentations like flipping, cropping, rotation, and brightness adjustment. These steps improve model accuracy and generalization. Our system consists of two main modules, YOLO VA detection, spatial graph construction module. First, YOLO VA detects people in aerial images, then spatial graph are used to analyze neighboring crowds, regions, and improve localization accuracy. Feature engineering, we extract spatial graphs features like node degree and edge weights. Contextual features like local crowd density, features such as scale and illuminations. These features helps improve crowd understanding in dense areas.
Let's see about the coding part. First, import session. For that, we are importing required libraries like Flask, YOLO, OpenCV, Gemini AI. We are using Flask for web application, YOLO for object detection, and OpenCV for image processing. And we are using Gemini AI also for people counting and recommendation. And other model handlings like file operation like OS, security, password hashing, data storage, JSON like that. Then for app configuration, we are initializing Flask app and setting secret key for session security and define upload folders for images. Load environment variables using .env. Then user data management. We are using load users and save users. Load users for read users from JSON file and save users for saves user to JSON file, and this is used for registration and login system. Then next, Gemini API setup. Reads API key for environment, configures Gemini AI. If the key is missing, it shows warning like that. Then YOLO bounding box function. It reads upload images, detect object using YOLO results, draws bounding box using annotator, and saves output images in prediction folder. Then object detection function. It loads a trained YOLO model in a best.plot and perform detection on images, count detect an object using counter and calculate image of number. Then we are using Gemini people counting. It converts image into base 64 format and sends image to Gemini AI. Then uses prompt to get people count X and extract number of response. Then we are using a Gemini recommendation like health tips, awareness messages, and based on the number of people detected, if API fails, default tips are drawn. Then for router like web pages, we are using home, register, login, logout, index like that. Routers are to redirect to login if the user not logged in. Then in register takes user to validate input and stores hashed password. In login, verifies user credentials and create session. In logout, clears session and index main page after login. Then image processing. It checks if image is uploaded and validates file type and saves image to folder. Then for the image processing, the processing is YOLO, Gemini and generate health tips. In YOLO it detect objects and Gemini it count people and generate health tips. Then result display sends data to HTML page, it upload image, detect image, it will count people, detect method and it will recommend health tips. Then the final step is to run application. Debug equal to true, that is for development. Starts Flask servers. This code builds a Flask web application where users upload images. YOLO is used for object detection and Gemini AI is used for count people and generate health recommendation. The results are displayed on the web page.
Our project is an AI powered people detection and health analysis system. This system uses YOLO for people detection, and the main aim to analyze, upload image, detect people in the crowd, and provide useful health related insights. So this is the homepage of our project. Here users can see the project title Advanced People Detection System, and a short description explains this system uses to a detect and analyze people in images. There are two main options: get started for new users, login for existing users. So registration page. For new user, the system provides a registration page. User enter username, email address, password, confirm password. After filling the details, users can create the account securely. Login and dashboard. After logging in, users are taken to the dashboard page. The dashboard welcomes the users and show key features of the system: AI powered detections, health recommendations, smart crowd analysis. This is our image upload section. Here users can upload images by clicking to browse files, dragging and dropping the images. There are maximum files of 10 MB. This makes the system easy and user friendly. After uploading the image, the user clicks on the analyze image. At this stage, the system processes the image using YOLO object detection. It detects the number of people's presence and identifies crowds, density and distributions. And it can once it detection is completed, it gives a health and safety recommendations: maintain safe distance, avoid crowding, take preventive measures. So this makes the project useful for public places, events, hospitals, emergency crowd monitoring.